On your whiteboard, you are going to answer the question using one letter only. So read the question, give about 30 seconds to think about it, and then we're going to share our answers. Write the letter nice and big. 10 seconds and you're holding it up. There should be no talking. Just what you know. If your marker doesn't work, I hope you're not putting it back in the bucket because that doesn't make any sense. Oh, you did? Oh, just show me later. All right, hold up your answer. All right, we got a few different answers, but most of you answered A, which is correct. Remember that phrase, he vanished without a trace. That means he disappeared without any sign that he was there. The trace is just evidence of an organism. It's not the actual organism, so it's like footprints. The actual organism that made the footprint is not there, but the footprint is preserved in a fossil. Number 2, what type of rocks do we most commonly find fossils? Five seconds. All right, hold up your answers. Brooklyn, hold up your answer. Yellow marker. Get rid of those. Thank you. All right, good. Sedimentary rock, because all the other rock either melts or is under extreme heat or pressure, is not good for preserving fossils. Sedimentary rock, sediments form around the fossils. Last one, if I want to get an accurate age of rock, which do I use? Five seconds. answers. Ooh. We got some seriously mixed answers here. All right. What's a key word I can pull out of that question? Accurate. Right here. Don't worry about it. It's our last one. All right, if I want to get accurate, do you think by me saying rock layer C is older than rock layer B, is that very accurate? It's really relative. You're not giving any numbers. If I want to get as accurate as possible, I need to not use the law of superposition. So if you answered B, that's not it. Law of superposition use relative dating. They're the same thing. So A's not it. It's got to be C, radioactive dating. You are counting the number of radioactive isotopes to get an exact, absolute, accurate age. All those words mean the same thing. All right, one person from each group. Collect the boards and pens and put them up, please. All right, few announcements while multiple people are up that shouldn't be up. We've got a canned food drive, like Mr. Gale is saying. I really don't want my class to be the one class that doesn't donate any canned food, so bring a can in. I mean, Thanksgiving just happened, so if you got a can of cranberry sauce that didn't open, bring it in. Also, tomorrow night is curriculum night, which is kind of like open house. There's a schedule that was sent out to your parents saying, I think from 5:30 to 6. He's going to talk to them about some stuff going on, update them on things, and then from 6 to 7, families are free to come to core classes. So we'll all be here downstairs tomorrow showing off your work and everything. And then from 7 to 8, I believe, is elective classes. All right.
Wait, so this is like a PPE?
Huh? It's like the first part is a meeting, and then like after that, it's just kind of like a walkthrough. Hey, what's going on? What are you doing? I mean, if there's a parent we need to, snag and have a chat with, so be it, but that's not our thing. All right, I'm not cutting anything out yet. Everybody get one? Do not cut anything out yet. All right, so we have talked about the age of the earth and how we know how old stuff is, like fossils and rocks. And now we're going to be tying that geology to evolution and how things have changed over the years, and not just organisms, but how the earth has changed as well. We did an activity a couple weeks ago, putting a puzzle together. Aaliyah, pick your head up. On Pangea, and how we use some evidences like fossil records and mountain chains to show how the earth looked differently millions of years ago, and now the continents are all spread apart. So what we're going to be doing today is talking a little bit more about plate tectonics. I'm not going to spend a ton of time on this because this is a review from 6th grade. So believe it or not, you covered this not too long ago. This is already updated online. So if you feel like you missed something, you can always go back and get it. Let's make it bigger. Let's make it bigger. All right, so your first vocabulary word is going to be plate tectonics. So remember, that is going to go on the outside. So if you guys haven't folded it and you're not writing on the back, you're not doing it right. I know it's been a minute. So when you fold it, you should still be able to see the dark lines, but you're going to write on the outside. Remember, that's the flap that you're going to open. So you're going to write your words on the outside and the definition on the inside. Other way now. Hold it the other way. Yeah, just the word on the outside, so you're writing the word. Plate tectonics right there. Definition right there. Alright, so plate tectonics is a theory. It's not a law, but it is a theory that says the Earth's crust is made up of giant plates that move over the mantle. Y'all remember what the mantle is? What's the mantle of the Earth? It's inside the Earth. Is it a solid, liquid, or gas?
Solid.
Crust is solid. Mantle's a really thick liquid. It's melted rock. It's like magma. So this plate tectonics theory says that the crust, which is what we stand on, is separated into big chunks called plates, and those plates are moving around on top of this liquid rock called the mantle. And because of this constant movement, scientists are theorizing that the Earth looked a lot different a long time ago than it does today, and that it'll look a lot different millions of years from now than it does today. Because it's still moving. And this is an important part of evolution and why some species have changed. I don't like this on Google Slides. There, I like that. Yeah, that's okay. I like being able to go down halfway. Now the crust is made up of dozens and dozens of tectonic plates. There are 7 major ones, but there are a whole bunch of tinier ones too. tectonic plates, the major ones, are usually named after what continent is on them. So, what continent do you think the North American plate is sitting on? Or what is sitting on the North American plate? What continent? North America. What continent do you think is sitting on the African plate? Africa. All right, the crust is kind of like the crust of a bread. It's on the outside. It's the thin layer of rock. When we say thin, it's not like paper thin. It's thin compared to the other layers. It's a thin layer of rock, and it's the outermost layer of the earth. The crust is what we stand on. Humans have never dug deeper than a fraction of the Earth's crust. So we say it's thin, but it's actually several miles thick. Next word is lithosphere. What shape is a sphere? Circle, round, like a ball. So when we talk about layers of the earth, whether it's what the earth is made of or the air around the earth, we're talking about spheres. Like hydrosphere is the water all over the earth. Lithosphere is the rigid outer part of the earth. Did everybody finish with the crust? Who's not finished with crust? Who didn't finish their crust? All right, the lithosphere includes the entire crust and just a teeny tiny part of that mantle, that very, very top part, where the mantle starts to turn into crust. So lithosphere can be a little bit hard to say, but the next one is even harder. Does anybody know what the next layer underneath lithosphere is? Hmm? It's called the asthenosphere. Asthenosphere. The asthenosphere is the very upper part of the mantle. So you've got this big layer of melted rock. It's very thick. And the very top layer underneath the lithosphere is the asthenosphere. And this is where we have movement. This is where convection currents occur. This is what causes those crust plates to move on the earth. As the mantle swirls through those convection currents, it causes the plate sitting on top to move in certain directions. Now those crust plates move extremely slowly. Usually about 2 centimeters a year. Bless you. So it's not like we'll be sitting here and all of a sudden we'd feel it move. Next word is convection. Again, this is something we talked about in 6th grade as far as heat transfer, conduction, convection, radiation. Those 3 words kind of ringing a bell? Ooh, I hope so. So convection is when you have movement in a fluid due to heat. It could be a fluid gas or a fluid liquid. This is why we have weather patterns. Heat is moved in the atmosphere. And depending on how that heat is moved is whether we get rain, when we get wind. It's also what happens when we boil a pot of water. We set the pot of water on the stove. Water heats up at the bottom, and as it heats up, it rises. And the heat that's on top, that's cooler, gets pushed down. As things heat up in a fluid, they become less dense. So you have fluid that gets hot, and as it gets hot, it gets less dense. And we know from our chemistry unit that the less dense something is, the more it rises. That's why we have ice that floats on top of our water. Don't pick your head. And then as that fluid cools, it starts to sink back down. That's supposed to be cooler, more dense material sinks. Change that right now. There we go. And this pattern continues. Fluid gets heated, it rises, it cools, it sinks. Over and over and over. So that fluid is moving in like currents, and those currents push the plates that are floating on top. when those plates move, you know, they're really close together. We don't have huge gaps in the earth. When they move, they can move a few different ways. And depending on how they move is what happens on our Earth's surface. So is anybody remember convergent, divergent, transform boundaries? Yes, no? Okay. Ooh, I need to talk to your 6 grade science teacher. All right, convergent boundary. When you have, and y'all don't drive yet, so you may not know, but when you have lanes that converge, they're coming together. That's usually when traffic happens on the highway. Convergent is when you have two tectonic plates heading right for each other. Depending on what happens, whether those two plates smash into each other or one goes under the other, is what happens on the surface. That's the difference between a mountain range and a bunch of volcanoes, or volcanoes and a big trench. We'll talk about that in a minute. When you converge, you're coming towards each other. Last year, some 6th graders demonstrated by chest bumping each other. I'm not going to make y'all do that unless you just feel the need. I think so. If the spirit moves, you go right ahead. All right, Divergent. Who's read the book or seen the movie Divergent? So in that movie, Tris, the main character, is different from everybody else. That's why they call what she is divergent. Divergent boundary is where two tectonic plates are moving in different directions or away from each other. They're separated. This usually happens under the oceans. There is a couple places on continental plates where this is happening, like in Greenland. When you have two tectonic plates moving away from each other, what do you think comes up in the middle between them? So if I've got two plates sitting on a surface of molten rock, and those plates start to move apart, what's in between those two plates? What is it exposing underneath it? What is it sitting on? It's sitting on molten rock. So when you open it up, what do you see? Molten rock. So when you have two tectonic plates moving away from each other, that's causing the stuff from the mantle to rise to the surface. So all that magma sitting underneath the crust is able to come up. This is where we get new crust from. Remember, the rock cycle is a cycle, like a recycling program for rocks. New rocks are being formed all the time. This is the way we get new crust all the time too. Some of our crust goes down and becomes melted. Some of it comes back up at divergent boundaries. All right, the last type of boundary is transform boundary. It's when you have two tectonic plates moving past each other. And this can either be vertically or horizontally, side by side or up and down. And the main thing that happens here is earthquakes. So if you have two tectonic plates resting against each other, and they start to slide in either direction, that's a rough movement. Those crusts are just scraping against each other, and that scraping is what causes earthquakes. So the San Andreas Fault in California is a transformed boundary. That's why they get a ton of earthquakes there. Bless you. Mm-hmm.
Is there any certain things that cause these plates to move?
Cause them to move? It's the movement of the mantle underneath it. So the currents of the liquid underneath the rocks kind of push them. Like if you had, you may ever, okay, this might be showing my age. They may ever made like paper boats before, or something where you float them on the water and you blow on them and they move. So if you ever take like, okay, how about this? You ever seen a leaf floating on the water? So what's making that leaf move is the current of the water. That's the same thing as what's making our tectonic plates move, except instead of water, it's magma in the mantle. It's just not as easy to see as a leaf on the water because it's very slow. All right, last one. It's called subduction. Sub meaning underneath or lower. Subduction is when you have a less dense tectonic plate. Wait a minute. Nope, nope. Tell it what it's pushed under a. This is why. 8. It is late. I'm still on West Coast time. All right, this is when a more dense tectonic plate is pushed under a less dense one. And this happens at convergent boundaries. So that's what I was saying earlier. When you have two tectonic plates coming at each other, either they're going to smash into each other and form mountains, or one's going to go underneath the other, and it's going to cause subduction. And at subduction boundaries, you have either a trench form, or you have a line of volcanoes form. All right, when you're done copying this down, you can go ahead and cut these out. Where I want you to glue it onto page, if you're following me, you're going to glue it onto page 42. I want you to glue it all the way to the left side of the page so that you still have half the page left open. Alright, look up here real quick. Look up here real quick. I need to see eyes up here. Gentlemen, stop cutting. Eyes up here. There we go. So when you glue it in after you cut it out, put it all the way to the left side of your page. So this leaves the other half of your page open because we got a few more pictures to draw. So you might want to skip that picture.
It's in my blue notebook.
Alright, take another minute to glue it in. Alright, yeah, one more minute and we're moving on. Lightning red, not very red. right. So if you want to use colored pencils for this next part, you can. There should be a few in your box. You do not have to though. We're going to draw a diagram to remind ourselves about what the inner part of the earth looks like. This is what I want you to record, bless you, beside your vocabulary foldable. That's why I had you leave that smidgen of a page. So in the earth, we have a bunch of different layers. The layer that we're standing on is called the what? What's the part that we stand on? The crust. Please stop talking. Thank you. Now the way I've drawn it up here, it just looks like one big chunk, but remember that the crust is divided into plates, dozens and dozens of plates. It's like a big giant puzzle floating on top of liquid rock. Now the layer below that is what a crust sits on. What is that called? In our vocabulary. What is the layer of the earth that the crust sits on? Starts with an M. Mantle. Thank you. The mantle is thick liquid rock. And it's extremely hot, and it gets hotter the closer to the core that you get. So that's what causes our convection currents. There are two layers of the middle part of the earth, which is called the core. The outer core. Anybody remember, is that liquid or solid?
Solid.
It's liquid metal. This is the reason why we have a magnetic field around the earth. Is because that outer core is swirling around the inner core. Now the inner core, the very center of the earth, it's super hot. How have I never noticed that the green pen is actually black? Inner core is in the middle. It's the hottest part of the earth. It is extremely hot, but it is a solid. And that's because the center of the earth is extremely high pressure. And it's so high pressure that it contains that metal into a solid. It's like a ball of very hot, solid nickel. Same page, hopefully. If not, make it fit however you can. You're gonna record the different boundary movements. We talked about them in our vocabulary. Convergent. Expect to see an arrangement in your future. We'll be changing some stuff. Convergent boundaries. We have two tectonic plates moving together. And if neither one of them goes down, they both smash into each other. This is going to call mountain chains. Like the Appalachian Mountains, like the Himalayan Mountains. If they have one that goes under the other, this is called subduction. And this forms either volcanoes or trenches. This is most common when you have an ocean plate, a continental plate. Usually the ocean plate goes down because it's more dense. Divergent. Plates are going different ways. This is where we have new crust forms. This is commonly seen under oceans, and they cause mid-ocean ridges. So it's that new crust forming, creating these ridges underneath the ocean. This is where new Earth is. Also called seafloor spread. Last notes. Transform boundaries. This is where you have two tectonic plates sliding past each other, either vertically, horizontally. And what we see there, earthquakes. In places like this, it'd be hard to do the law of superposition because those rock wedges are probably disturbed quite a bit. So make sure you have all those copied down. If you had to carry over to page 43, that's fine. Just make sure your table of contents reflects that. But I write pretty big, so most of you probably were able to finish that out on page 42. When you finish copying it down, you can put your notebook to the side. Alright, we have just enough time to go through this brain pop. About 6 minutes long. Make sure your name is on the worksheet. Questions do go in order.
Are you sure this thing is rated for this depth? You bought it from an airmall catalog. Oh, great. Dear Tim and Moby, when I look at a map, it seems like some continents fit together perfectly. Are my eyes playing tricks on me? From Georgia. You're not seeing things, Georgia. Some continents look exactly like puzzle pieces that snap together. Early map makers suspected that they were once all connected. In the early 20th century, a scientist named Alfred Wegener called this supercontinent Pangaea. He thought different chunks of it broke off and slowly moved apart. Over millions of years, they formed the continents we know today. Wegener couldn't explain why Pangaea split up or how. But there was some evidence to support his idea. Fossils from similar plants and animals had been found oceans apart. The age and type of rock layers matched up too. Wegener's theory of continental drift provided an explanation, but his ideas weren't taken seriously until long after he died. In the 1950s, scientists began mapping the Mid-Atlantic Ridge. It's a mountain range running 10,000 miles along the ocean floor. Tests revealed that the farther you got from the ridge, the older the seafloor was. So a geologist named Harry Hess proposed a revolutionary idea. New seafloor was forming at the ridge and spreading outward to make room for more. In other words, the surface of the planet was moving. Hess called this process seafloor spreading. It seemed to indicate that rock was being forced up from inside the planet. Nowadays, we can see this rock formation in action. Wegener had guessed something like this, but he had no way to prove it at the time. As he suspected, there's a lot going on beneath the Earth's surface. Up here, everything seems pretty cool and stable. But miles below our feet, it's a raging inferno. The deeper you go, the hotter it gets. Earth's center, or core, is as scorching as the surface of the sun. All that energy wants to escape, like steam inside a boiling kettle. It pushes outward, putting immense pressure on the middle section, the mantle. Standing in its way is the lithosphere, a rigid layer of solid rock. Well, the lithosphere isn't like a smooth shell. It's cracked into pieces, each one a different shape, size, and thickness. We call those pieces plates. Yep, the Mid-Atlantic Ridge is the border between several plates. They're being dragged apart by forces from deep inside the planet. You can think of it like a pot of soup. The Earth's core is the burner, and the mantle is the boiling soup. As the soup near the burner heats up, it becomes less dense and rises. When it gets to the top, it cools off and sinks down toward the heat. In physics, those are called convection currents. A similar process is driving the mantle, and it's taking the plates along for the ride. That movement is called plate tectonics. It's the engine driving the constant transformation of our planet's surface. Plates have been bouncing off each other for eons. The oceans have expanded and contracted. Land masses have smashed into each other and broken apart. The plates move about as fast as your fingernails grow, so we don't see the ground sliding around under our feet, but we do sometimes feel it. Yep, I'm talking about earthquakes. Seismic activity is greatest along plate borders, at convergent boundaries where two plates collide, at divergent boundaries where they pull apart, and at transform boundaries where they slide past each other. At all three boundaries, there's enormous pressure on the Earth's crust. That's the topmost layer of the lithosphere. The pressure can build up for years. The longer it takes to release, the bigger the earthquake. Yep, and plate movement drives volcanic activity too. At divergent boundaries, like the Mid-Atlantic Ridge, there's a gap in the lithosphere. So magma, molten rock from the mantle, is constantly pushing up along the boundaries. These are the most volcanically active places on Earth. Volcanoes are also common at boundaries called subduction zones. That's when a dense ocean plate converges with a lighter continental plate. The heavier plate gets pushed below, down into the mantle. Some of it melts, and the magma erupts farther inland. The Ring of Fire is a massive chain of these volcanoes. Dense sedimentary rock making up the Pacific seafloor is subducted, transformed into metamorphic rock through pressure and heat, and then recycled as igneous rock through volcanic eruptions. In other words, plate tectonics drives the rock cycle, the constant process of transformation and renewal of the Earth's crust. It also creates our most prominent geologic features, mountain ranges. That happens when two continental plates converge. Since they're both about the same density, neither one subducts. Instead, it's like a slow-motion car crash. The plates buckle and warp. The land pushes up into jagged peaks. The Himalayas are still growing from a plate collision that began 50 million years ago. Yeah, Alfred Wegener's theory has come a long way in 100 years. He was practically laughed out of the scientific community for his ideas. But today, plate tectonics is the unifying theory that ties together the entire field of geology. What do you mean, out of juice? We're stuck here?